Okay, so let's prepare our high-res sim, our high-res grain sim. Let's go to the grain source. And I want to make this a little bit thinner, so we go to the poly extrude node right here. And I want to do 0.29. Okay, so it's a little thinner than it was before. So this will make our smaller rocks stick out a little bit better. So before we increase the particle count here, let's go to the grain sim. And I also wanted to decrease the repulsion weight a little bit. So we go to our grain collisions, repulsion weight, let's do 0.2. So that should help out the pushiness of the grains a bit. And I want to increase the attraction weight slightly. Let's do 0.057. Okay. So I think we're all set in here. So let's increase our particle count. So in the grain source, and let's increase the particle amount. So we're going to reduce the grain size. So we're looking for something around 10 million. You can also do 6 million or 12 million. It really depends on the spec of your PC and how much time you have. Let's see 0.02. $7.5 million. So increase it a bit. So we'll do 0.018. Okay, that's right on the money. 10.4 million. So I think this is gonna be the number we're gonna use for our high-res grain sim. So we'll check the jitter scale. Okay, so it's done jittering and it jumped just under 10 million. And I really want to cross the 10 mil barrier, so I'm just gonna say 0.175. And I'm just gonna do this again because I really want to have 10 million points. So I'll be right back. Okay, so 0.0175 will get us over the 10 million point. So this is what I'm going to work with. Let's go to our render grains. And half our image is now disappearing, and this is due to me not having enough memory for this, but that doesn't matter. So when I cache this out, it will all be there. So let's go to render grains. And let's go to our DAP import field. Turn off the color node. And let's hide this stuff. So now we should only see our grains here. That's looking like a nice blanket. Okay, so let's turn off this smoke thing and just say no change. So we have our DAP network grain sim and we have our vellum object 1. So now let's add a file cache in here. And let's call this render grains cache. Okay, so let's save this to $job again, so $job. And then we'll choose our sim data folder, sim data. And then we'll say /$os. So we'll make a folder called render grains cache. And we'll say another /$os for the name. And we'll say $f.bgo.sc. Okay, so that's looking good. We want to do frame 1 to frame 275. Okay, so everything is looking good. So now it's time to save this to disk. So we'll save the cache to disk. Okay, our cache is done. So let's load this from disk. And now we can scrub through this. But it is going to be a bit slower than we're used to because it's so many points. 10.6 million to be exact. And that's looking really nice. So let's go to the first frame and let's go to our object level. What I want to do is I want to make a flipbook of our scene here. So let's hide some stuff and let's get our render grains, our render rocks, our ground plane and our ship geo in. And then let's do a flipbook. And let's do frame 100 to frame 275, that's fine, and start. Okay, the flipbook is done. Oh, I love this whip here on the bottom left. Alright. It's looking cool, I love this whip here. You know, the wing, because of the weight of the stone, I banked the ship a little bit and it kicked up some grains on this wing on the other side, and it's looking really cool. Yeah, so really happy with this. We could also see some stones poking out here. We have the big rocks. The big rock is really colliding with the grains here, so that's looking cool. Oops. One issue I had is I didn't have enough space on my hard drive, so it didn't cache the last 10 frames. Because you know it's almost 1 gigabyte per frame, so this is about 275 gigabytes. So I'm just gonna cache this again when I've made some room on my hard drive. And I'm gonna change a couple of things. I think I'm going to add a little bit more clumping. I'm gonna do that with the noise and then maybe add a little bit to our traction weight value, but just a little bit. And I'll also increase the thickness just a tad, you know, so we have a little bit more thickness on the grains here on the wings and on the ground, and yeah, that should be it. So let's do those minor adjustments. So we go into the grain source and so look for our attribute VAP because we're gonna play with the noise. And let's also get our color back so we can see what we're doing. So let's go in the attribute VAP and let's go to our fit, and I'm gonna change these values a bit. So I'm gonna do minus 0.7 and 0.7 on the max, so it's gonna fit between those numbers. And on our noise, let's increase the amplitude to 10. Yeah, I think that's about it. Okay, so let's go back to the grain source and we can turn off the color node again. Set the flag on our out geo. Okay, and let's change our attraction weight value a little bit on our vellum solver here. So we go to grain collisions, attraction weight, and let's change this to 0.07. Okay, now let's increase the thickness of our grain source. So we go back to the grain source. First, let's turn off our jitter scale because this will save us some computing time when we change the thickness. Okay, so let's look for our poly extrude here. And I'm gonna change this to 0.31. And of course, when we have a thicker layer, this is gonna give us more grains with the same grain size settings. So as you can see now we have 14.7 million. So let's change our grain size a bit. And let's see what that will give us. Okay, so 13, so still a little bit too much. Let's do 0.019. Okay. Let's also get our ground plane in. And let's quickly check if we have any grains poking through our ground plane on the first frame. So press 2 on the numpad twice. Okay, and we do have grains poking through the ground plane right now. Maybe that's because we've increased the thickness, but also maybe because I forgot to check this last time. So let's fix this. We'll do 0.1. Let's see if these spots here disappear. Not completely. 0.14. So they're now all on top of the ground plane where they should be. Okay. So this is looking good, 11.3 million, because when we turn on the jitter scale, this will it will be a little bit less points. So let's wait for this to calculate. Okay, so this will give us 10.5, 10.6 million points. So that's about the same we had last time, so that's cool. So let's change back to our camera. Okay, so one last thing. When I checked the render view to see if everything was okay, so I rendered at frame 100 when the grains have settled, I noticed that overall it looks good, but we have some spots here where the grains don't lay on top of the ground plane. So there's a gap here. And this is because our solver, our collision solver for the ground plane is using a volume. And on the side effects forum, I read that if you want more accurate collisions, you need to disable the volume-based collisions on the static object. So we want more accurate collisions because it's not matching up in here. So what we do is we go to the grain sim, and then we go to the ground plane, collisions, and then we just uncheck use volume-based collision detection. And this will fix our issue and we can move on. Okay, so now that's fixed. I will just cache this again, call it V2 and let it run overnight. Okay, so here's the new improved V2 of our grain sim. Alright, it's looking great. So you can see the grains have settled a little bit differently on the ground plane since we disabled the volume-based collision checkbox. And this is looking even better than it did before, if you ask me. So I'm very happy with that. I also increased the thickness a bit, and we also increased the clumping a little bit. So this is looking great now. And up next, we're going to play with our P-scale.